Alright, so this is the beginning of lecture 6 part 2. So in class we learned about inequalities and absolute value inequalities. So here we will present more examples so that you can do your homework easily. Right now, let's see. So first rule we learned is if there are any fractions where you can multiply by any positive number. So if there are any fractions, just make sure you get rid of all the fractions. Now let's see what we can do here. So this one I'm going to multiply by 6, and on the other side I have to do the same thing, so I'm gonna multiply this side also by 6. So why 6? Because the least common denominator of 3 and 6 is 6. Okay, now let's see. Remember, you have to do the distribution step, so you will end up with 6 times negative 2 over 3 x minus 6 is greater than or equal to x over 6 times 6 plus 5 times 6 is 30. Okay, now in here you can just cross this off because that's the same number, and 3 and 6 that would go off, and 6 is 3 times 2, so we will have 2 remaining. So at the end you get the same inequality, but here 2 times negative 2, that would be negative 4x minus 6 is greater than or equal to x plus 30. I would subtract x from both sides. Again, this is not the only way to do that, so negative 5x, and I will add 6 to both sides, greater than or equal to 36, and then just divide both sides by negative 5. And remember, when you divide by a negative number, this changes to less than or equal to, so you get x is less than or equal to negative 36 over 5. Now let's see how we would denote that on a number line. So let's draw a number line and put the arrow, and you have, let's say this number is negative 36 over 5, and x should be the same or less than that number, so it should be right here. So you can see it should be from negative infinity to negative 36 over 5. So the interval in interval notation should be negative infinity to negative 36 over 5. That's how you do it in interval notation. Okay, so let's do one more example, and here it's a different type. It's a triple linear inequality. So you have 3 components. Again, you will do the same thing. You will multiply the whole inequality system by 3. 3 because there's only one fraction, and that fraction has denominator 3. Okay, so okay, and then you would have negative 2 times 3, that's negative 6, and 3 is a positive number, so there is no worries about changing the absolute value sign. Less than 2 times 5 minus x, less than or equal to 12. Okay, so now I have 2 here. Well, in this case I can divide everything by 2. So divide by 2, divide by 2, and divide by 2. So you end up with negative 3 less than 5 minus x less than or equal to 6. So remember, your target is making sure only x is in the middle and everything else should go to the sides. Okay, so I'm not adding x's to all 3 sides, that would make x go to the sides. I'm going to subtract 5 from each side. So minus 5, minus 5, minus 5. that ends you up in negative x. Here you have 6 minus 5 is negative 1. Here you have negative 3 minus 5, negative 8. Now I would divide everything by negative 1 just to make sure I have x in the middle, but that would change the inequality sign. So just be aware of that situation. So that would make the inequality sign change, 1 here and 8 here. So x is between 1 and 8. So you have 1 and 8 and x is in between those. So you can write x is between 1 and 8. In interval notation, that would be closed interval 1 and open interval 8. Okay, now you can solve the inequality that you will see in a moment on your right hand side of the screen. Okay, so let's talk about absolute value inequalities. So things we learned in class. If the inequality is absolute value and you have absolute value less than the number a, where a is a positive number. Remember, a positive is quite important here. If a is negative, there are different cases. So in this situation, if absolute value less than or less than a positive number a, the absolute value inequality changes to a regular inequality, so without absolute value, but you have a triple linear inequality. And I hope I explained, you understood when I explained this in class. And then you have to solve that. Okay, so and also this is the first type, and the second type is still a positive number a, but you have the absolute value greater than a. And in this situation, the absolute value inequality splits, and the way it splits is what you have on the inside is greater than a, or what you have on the inside is less than negative a. So these are the two situations that we talked about in class when solving absolute value inequalities. And there are some more examples that have different types, but these are the inequalities we discussed in class. Okay, so if you look at the example number 1, you can see it's of type 1, where absolute value is less than a positive number. So it breaks up as x minus 5 is between 2 and negative 2. And you can see in this situation you do not have an absolute value. So it was originally an absolute value inequality. You made it a regular linear inequality by using this format. Okay, now all you have to do is solve it. Add 5 to all 3 sides. You're done. So you get 3 here, and you get x here, and you get 7 here. So x is between 3 and 7. In interval notation, that would be from 3 to 7. Now one thing you have to remember is if you solve absolute value inequality, you will have to make sure there is nothing in front of the absolute value notation in order to break it apart. So if there is something, just divide it or multiply it or do something to get rid of that. Now right here you can see that there is a negatives 2 that is unwanted. So I will divide both sides by negative 2. Now the regular rules of absolute of inequalities apply. So this becomes less than or equal to, because it's a negative number we are dividing it with. Okay, now let's see what happens. So this is gone. So we have 3 plus x over 2 greater than or equal to 2. Now that is type 2, absolute value greater than. Okay, which means this splits to 2. So you have 3 plus x over 2 greater than or equal to 2. That's your first inequality. And the second inequality will be 3 plus x over 2 less than or equal to negative 2. So let's solve these inequalities separately. So for example, let's do 1. And that would be so 3 plus x over 2 greater than or equal to 2. Subtract 3, you get x over 2 greater than or equal to negative 1. You subtract the 3 from both sides. And then times by 2, you get x is greater than or equal to negative 2. So in this you will get the inequality negative 2 to infinity. And inequality number 2 will give you subtract 3 first. So you get x over 2 less than or equal to negative 5 times by 2, you get x is less than or equal to negative 10. So here x is less than or equal to negative 10, so that would be from negative infinity to negative 10, including negative 10. Okay, and so how do you combine the final answer? As we learned in the lecture, you just combine them as a union. So negative infinity to negative 10 union with negative 2 to infinity, and that would be your final answer. And oftentimes when you have absolute value greater than or the second type, you will most probably end up as a union. So this is a sign that you have ended up in a correct answer. You will end up in a union of two intervals. Okay, now let's really quickly see how to do number 3. Again, it's absolute value greater than. So again, it splits to 2 separate inequalities. One would be 2x plus 1 greater than or equal to 3. That's inequality number 1. And the other one is 2x plus 1 less than or equal to negative 3. So let's solve inequality number 1 first. Subtract 1, so you get 2x greater than or equal to 2. Divide by 2, x is greater than or equal to 1. So that would be 1 to infinity. Let's do equation number 2. Subtract 1, 2x less than or equal to negative 4. Divide by 2, x is less than or equal to negative 2. Less than or equal, so that would be negative infinity up to negative 2. So in order to write the final answer, you will combine them using a union. So negative infinity to negative 2 union 1 to infinity. Is it wrong when you write 1 to infinity union negative infinity to negative 2? No, you're not wrong. This is like the conventional way of writing it. Okay, now let's go to the next question. Look at the right hand side of your screen, answer the question and press continue. Alright, so one application, as we discussed in class, of inequalities is finding domains. Especially you have to find when you have to find domains of square root expressions. So remember what I mentioned in class, if I ever did. If you have a square root and if there's something inside, when I ask you the question domain, okay, take that thing out. So without the square root, and set it greater than or equal to 0, because square roots cannot be negative. Square roots should be non-negative, that is either 0 or positive. So you have to make it greater than or equal to 0 and solve it. So there's a really nice example in this example 1. You have square root of 3 plus 2x and the question is domain. So you will take the inside without the square root, 3 plus 2x, set it greater than or equal to 0 and try to solve it. And that's as easy as an inequality can get. Subtract 3 from both sides, you get 2x greater than or equal to negative 3. Divide both sides by 2. So you get x is greater than or equal to negative 3 over 2. So that's the answer, that's the domain. So just finish the question by writing it in interval notation. X is greater than or equal to negative 3 over 2. That would be negative 3 over 2 to infinity. So that is the domain of the expression, which means you can put in any number from negative 3 over 2 to infinity and get a valid expression. Whereas if you put anything below that, you will just get a non-real number. Okay, so that's what the domain means. What does it accept? It doesn't accept anything below negative 3 over 2. For example, it doesn't accept negative 10, because if you plug in negative 10, you will get square root of negative 17, which is not a real number. Okay, I hope you got that idea of domains. Alright, so very similar in the second example, 1 minus x. So the question is about the domain. So take the inside and set it greater than or equal to 0. So subtract 1 from both sides. So you get negative x greater than or equal to negative 1. Divide both sides by negative 1. You get x is less than or equal to 1. Remember we divided by a negative number, so that changes. So that is the domain, and in interval notation that would be x is less than, so negative infinity to 1. Okay, now the third example is very slightly different. The reason is you have it in the denominator. The square root is in the denominator. Now the correct way to solve it, so this is the general situation. You have a number, let's say 1, over square root in the denominator. Now, and I ask you for the domain. Now in this case, the square root, the inside of the square root cannot be negative because negative square roots are not real. Also, it cannot be 0 because that would give you 1 over 0. Therefore, it cannot be negative number or it cannot be 0. So, the correct way to solve is make the inside greater than 0. Rather than greater than or equal to 0, make it greater than 0 and then solve the resulting inequality. Okay, so I hope you got that. So let's look at how to find the domain of this. So you have this 2 plus x, take that guy out, and because it's in the denominator, make it greater than 0. And then just solve it. Negative 2, negative 2, so you get x is greater than negative 2. That's it. X is greater than negative 2, that would be from negative 2 to infinity. Alright, so the last example for lecture number 6 is this word question. Now you can see it on your own notes, lecture part 2, page 6, lecture 6, page number 12. And we did one of those examples in class, but we just did this first part. So let us do it again, and we have a little more time here because it's a video. So Remember, this is about product, revenue, and cost. So this is a finance type of question. So the things you need to remember is revenue is equal to units produced times the demand or the price. So I will use these two words interchangingly. So whenever I say the demand, it's the same as the price. This thing is the same as the demand. So a very easy example is if you sell an apple at $5 and you sell 12 apples, what's the revenue? That would be 12 times 5, which is 60. Okay, so the same idea goes into everything: units produced times price. And in finance questions, we always make the number of units produced to be X. So that's the variable that we always use unless otherwise specified. So this is your variable X. So revenue is equal to X times P. Okay, and also there's something we discussed, the cost. The cost is equal to, sometimes we have to have a fixed cost which is to cover the initial expenses, and then to produce each item you will have a marginal cost. That's what we call it. So the cost function is equal to the fixed cost plus unit produced times cost per item. Okay, so that we discussed in class, and this is a really quick summary. So let's see how this goes. So a company can sell a new product. So they can sell it for new product, sell it. So this is the price for $19. If the cost to make this product is 8 per unit, so this is cost per unit. Now there's a small typo here. It should be plus a fixed cost of 88. So this is the fixed cost. What would be the cost expressed in terms of X, the number of units produced? Okay, now let's do that quickly. So the cost is equal to cost per item times number of units produced plus fixed cost. Now once you read the question, you can identify each of these, what variable or what constant each of these refers to. So cost per item is $8, unit produced is X, fixed cost is 88. So the cost is 8x plus 88. Okay, so the reason that you don't see the thing is I have used a word processor that use FI as a single letter and it didn't fit here. So if 1 week the daily profit from the sale this item is ranged to 44 to 110, or what range the daily sales vary that week? Now that looks like a really confusing question. But let's look at in parts. Okay. Now daily sales is how much you sell, so how many units you sell, so that would be your X. Now profit is always revenue minus cost. And you have found the cost function right here. So you will have to find the revenue function. That is not hard because revenue is X times price. So revenue is price times X. And the price itself for $19, so it's just 19x. So the revenue is counted as 19x. So now you can actually do this. The profit, big P, is equal to revenue, which is 19x, and the cost is 8x plus 88. So 19x minus 8x plus 88. So that would be production. The profit is 19x minus 8x, that would be 11x minus 88. And it says if 1 week the daily profit from the sale of the items range. So this thing range, so that would be in between 44 and 110. So you will have this inequality, and they are asking for over what range did the daily sales. So all you need to do is solve for x, because once you have it solved for x, you will get, because x is the daily sales. Okay, so let's add. Well, I can see that everything is divisible by 11, so I'm gonna just divide everything by 11 just to make things easy, just to get nice fractions. So you get 10 here, here you get x minus 8, and here you are going to end up with 4. And when it says range, it means less than or equal to and greater than or equal to. So it can be 44, it can be 110, it cannot be above or it cannot be below. So add 8 to all three sides, you get 12x and 18. So the amount sold range between 12 and 18. So this is how you convert it to words. Amount sold, or which is the same as daily sales, range between 12 and 18 units. And that's how you get your final answer. So mathematically, actually, you solve a very simple inequality, but converting the words to a nice mathematical model, that was the challenge here. So I hope you enjoyed the lecture and answer the question at the end of this lecture.